And with me is the organizing committee, Norbert Rode from PTJ in Germany, and also Alicia Stocklose has been on the organizing committee. She is with Georg supporting all the work of the TRI4 Heating and Cooling. It's a webinar, so there are a few organizational details I have to go through with you. We are planning to record this meeting, so be aware of that. We encourage you to not be shy and put your questions either by raising the hand during the questions and answers session or by putting your questions in the chat. Then we can address them during the questions and answers session, but also after the meeting. We hope that your questions are answered as well. A few words about the Clean Energy Transition Partnership. If you're not aware of the nature of the Clean Energy Transition Partnership, we are a collaboration between funding organizations. And what we're doing is bringing together funding from various countries. It's more than 30 European countries that collaborate in this CET partnership. We are bringing that funding together to fund joint projects. We are organized as the Clean Energy Transition Partnership in several thematic areas, and heating and cooling is one of those areas. You can see that we're working on a technology level, but also on a user-centric and an overarching system level. But you're here with the Heating and Cooling Transition Initiative. And when it then comes to heating and cooling, we can think about solar thermal. We can also think about geothermal. But today, the solar thermal technologies are in focus. We want to highlight the transformative power of solar thermal energy and share with you potential recent developments, hear about the ongoing projects on solar thermal in the CET partnership that come from the 2022 call. So we will, in a way, set the scene of this research and innovation collaboration that we want to emphasize and strengthen on solar thermal, and we want to make you aware of what's ongoing, what the environment is for these technologies, but also make you aware, of course, that there will be a new call with new potential for you to be involved in funded projects. And without any further ado, I now pass on to my colleague Norbert Rode, who will introduce the agenda very briefly to you. Norbert, please.
Yes, good afternoon. My name is Norbert Rode. I'm from Project Management Jülich, and I am a contact for Germany in the TRI4 Heating and Cooling. After our short introductions, there will be two short presentations about two projects that are funded in the call from 2022. Strawberries is a project about large-scale solar thermal collectors and fields for district heating. PVT for EU. Another project that aims to thermal use of the sunlight, and this is followed by an overview from Solar Heat Europe with about existing developments and market trends in Europe. After this, Klaus Lichtenegger from BEST will introduce the IEA SHC task 68, which is working on large solar thermal systems for district heating. And then we become a bit more concrete. There will be 3 presentations about the situation in the Netherlands, in Denmark, and in Germany. Thank you.
So with that, we've come to the end of our introduction, and I can introduce to you the first speaker, who is Thorsten Zung. He will be presenting about the project Strawberries, which is one of the funded projects in the CET Partnership Joint Call 2022. Thorsten, the floor is yours. Thank you very much.
Yeah, so thank you very much, Redi and Norbert, for the kind introduction. I would like to introduce the Strawberries project to you, which is about the efficient combination of solar thermal energy and agricultural land use, which we try to achieve through the usage of bifacial insulating glass collectors. I will explain later what exactly that would mean. But first, let me briefly introduce the motivation of the background behind the topic. We realized that there's limited land availability, which is slowing down the expansion of these large-scale solar heating systems. So as we can see here in this picture, for example, these systems take up several thousands of square meters, and we saw that the competition for space is more generally an obstacle to solar energy. You probably are aware of this. And we already saw that there is an innovative and competitive PV solution for this, which we see also in the 2 pictures above, where we have highly mounted PV installations and combined the agricultural land use. And we also saw that in a different way, which is vertically installed bifacial PV modules, as seen on the right, which is seen to be a cost-effective system design to combine these 2 fields with each other. And we also realized that there's not yet a solar thermal implementation of that, also because there's no such kind of bifacial flat plate collector available that would allow for this vertical installation. So within a previous research project, we were heavily developing on the so-called insulating glass flat plate collector, which we see as a basis for this novel agri-solar thermal system that we try to develop within this project. So here we can see a prototype of that collector. And as you see, it looks pretty similar to conventional types from the front. But at the back side, as you can see here also, we have a transparent rear cover because of that glass assembly, which we would like to utilize to come up with bifacial agri-solar thermal systems. And that brings me to what we have in mind for the project. And you can see here a very rough sketch of what that system could look like. But if you see that we combine these agricultural land use with solar thermal, many questions come up and shall be answered in order to really successfully implement such a design. For example, what about the spacing between the rows of collectors so that agricultural activities are still possible, but also the solar yield is still in a range which we consider reasonable? What about the total space requirement of such a system? How much energy per square meter can we really get out of it? What about the crops? Has it implications? Which kind of crops can we really harvest in a reasonable way? What is the system design? What does it look like? What requirements does it have? But we have this kind of novel and special combination of 2 fields. Of course, obviously, what is the solar yield? And what about shading? Has it a special impact of these kind of systems? And many more questions to be answered. And within the project that is funded from the CET partnership, we try to first conceptualize such a system design by taking the requirements of the system, noting it down, and understanding what is the basic concept and what are the implications of these of this innovative way of designing a solar thermal system. But first, we will also like to do some simulation, of course, to understand that in a more comprehensive way, to estimate the solar yields and the different effects that we have before we go to lab testing, where we can validate our models and get some experimental results and see how this actually works in a real test before we actually go to the demonstration to set up such a system and understand and assess the potential of this kind in a real system. And we already started with the first analysis within the project, so we can already show you some first results when it comes to the shading of these systems. And for this, we took an example where you can see here the row spacing of 12 meters, a ground clearance of 1 meter, and 1.5 meter module height as an example. And we tried to understand what are the shading effects for that. Are they critical for the system design, and how to consider this in the next project phases. So what we did is an analysis of the incident angle and the shading. As I said, it's important to understand what the system effects behave and also to see that in comparison to conventional systems. So what I'd like to show you first is the incident angle modifier, which shall represent as a value to assess the amount of power the system can provide compared to its maximum power. And we investigated that for a conventional south-oriented system with an inclination of 30 degrees. And as we can see here in this diagram, for the summer solstice day, we see nothing very spectacular. We know that the peak of the solar production is during the mid-time of the day. But now it becomes interesting to see what happens for the bifacial part, where we actually have a east-west oriented system. And we have the east side, which has as the first half of the day the energy production, and at the west side the second. And what we also saw is that the shading, which we see here in this orange line, is not heavily affecting the solar energy production in our example, but just at the very beginning and end of the day it becomes important. But as I said, this is just for this first example, and we'll try to continue with that investigations and elaborate more in detail. And for the winter solstice, we did a similar kind of thing. And as a summary, because I think my time is already up, we saw that this bifacial system has an increased seasonality compared to conventional systems. And the shading, at least for this first example that we calculated, was not that critical as we thought. However, it's important to continue these investigations for us to show what is this in the overall analysis, let's say, and in the final overview of this. But yeah, this was just what I wanted to show with you. And yeah, I'm curious to your questions. Thank you. I think we cannot.
Yeah, you are muted.
You. Yeah.
Yeah. Mm-hmm.
Yes, Thorsten, thank you. Impressive. There are some questions in the chat. One question is, did you calculate the impact of the wind load on the structure for vertical installations? Are there any experiences, or how do you think about it?
So this is something that we will consider within the research project. Within the previous project, where a similar kind of collector setup was analyzed, we calculated the wind and snow loads for a south-oriented, conventionally installed type, and saw that this would affect the glass dimensions that you have to specify, but this is something that we consider as manageable for the collectors. But it has to be considered, of course, for the design. Yeah.
Mm-hmm. It's raining questions, by the way, so I suggest that
Yes.
Thorsten would also look into the chat, and while we go on with the presentation, you might be able to answer some in the chat. That would be great.
Okay, thank you.
Thank you. Thank you for the interesting presentation.
Thank you.
We proceed with the next CET Partnership-funded project, which is PVT for EU, and Ivan Acosta is going to present as the project lead of the PVT for EU project. If you just could say a few words about yourself as well, Ivan, and the floor is yours.
Thank you very much for the invitation and to this event. For us, it's really a good opportunity to discuss and to share the objectives and the scope that we're planning to have in the project that was granted by the CETP partnership. As already it was introduced, I'm Ivan Acosta. I'm the project coordinator of the project, and I'm the head of engineering in MG Sustainable Engineering, which is an SME based in Uppsala, Sweden. And we basically have been developing PVT technology in the last 10 years, focused more on the research part. So now I have the opportunity to present with you the project that we are working on. Well, here I would like just to share the content that I'm going to be presenting today, general information about the project itself, the motivation that actually led us to apply to also to the not only to the project but to the joint call 2022, the project objectives, the specific goals, the work plan, and the partners that are involved in the project. As for general information, as I already mentioned, we prepare a proposal for the joint call 2022 for the CETP partnership. Actually, it was the first time that we were preparing this kind of proposal for this program in specific. And the good thing about it is that we already had some work in progress with the companies that were involved in the consortium. And actually, the CETPartnership was a great platform for us to not only to fund the project, but to also sustain it in time, to be able to reach higher TRLs in the development that we had. It is a 1.1 million euro project that consists of 6 partners, both in industrial and academic institutions. We started on September 1st, and we are hopefully ending on the 31st of August 2026. And let me go to the motivation. As many of you already know, the PVT technologies are gaining momentum in the market, especially in the European. But based on some on the solar heat worldwide report that has been including PVT for the last years, we have seen that the PVT market is growing. And I think that is a good motivation for us to continue promoting the technology and also developing technology that has to be more competitive in comparison with the ones that we have, and to also to promote new alternatives for solar technologies. We strongly believe that one of the main advantages of solar energy is that we have such a broad area of application, but also us as technology developers, we will have to make sure to define the limitations that the technology that we're developing has, and which are the applications that we should target. Some of the things that actually also motivate us to do the project is that even though PVT has been gaining momentum, we have also seen some companies in Europe, especially, that has been struggling a bit in selling the technology. It is a new technology. So the problems that solar thermal have at the moment are a bit more escalated with PVT sometimes, because it's a rather new technology. So we have a lot of things to do to gain the trust of the final customers, but not only that, but also to develop technology that can compete in the market. So actually that was the motivation for us in the project. And the project objective itself, it's to develop 2 PVT technologies. The first one, which is with one of the Swedish companies, which is called Solar Peak, is more intended to be applied, well, the applications in buildings. And we are calling it as a PV panel retrofit, where basically we're trying to take advantage as much as we can from the PV infrastructure that has been installed in the last decade or so, and try to convert them basically into PVT collectors with this high efficiency heat exchanger that we're trying to develop. Here you can see one of the renders of a technology that we're basing, but we are hoping to further optimize the design And as you see here, the targets basically are increase the performance, of course, increase the cost effectiveness, and lower the environmental impact. And this is a rather important aspect that we are going to be putting in the project, because sometimes when we develop technology, we forget about what is going to be happening when it's already reached the end of life. So we are going to be implementing some eco-design strategies in order to make sure that technology that we develop is also friendly with the environment whenever it has to be retired or decommissioned. The second technology that we're approaching is a rather enhancement of a previous technology of Solarus collectors. And we are hoping to have this technology to be reaching between actually 120 and 140 degrees, and for commercial and industrial applications. So we are going to be enhancing the previous design that they had. The specific goals that we have is basically develop PVT tech, increase the performance, both efficiency with the spectral splitting, and this one actually it's a new concept that we're going to be trying out in the Solarus collector, in the concentrating one. Implement predictive control that will allow us to actually see when we have to prioritize electricity or thermal production. As I mentioned before, integrate eco-designing strategies in the development phase of the collectors, and also establish a European innovation network, because we know also and we acknowledge that most of the PVT developers are in Europe at the moment. Hopefully that will change in time, but that will also mean that we have to build up a network of innovators in the area, so we can also share experiences there. Just for you to know, the partners that are involved, as I mentioned, MG is the project coordinator. We're going to be dealing basically with project management and also dissemination and communication activities, and also to the technical coordination of all the partners that are involved in the project. We have two SMEs. The first one is SolarPeak and Solarus, which are basically the PVT collectors producers. And they're going to be dealing with work package number 1, which is basically thermal strategies that will allow us to enhance the thermal performance of the collectors. Solarus is also have a good background with the impact assessment and the market uptake of these kind of technologies. So they're going to be focusing on that part, aside of supporting also the development phase of the collectors. And for the academic partners, we have the University of Gävle in Sweden. They are going to be helping us a lot with reviewing which are the latest advances in PV cells that we could use for the concentrating collector. Also to see and how we can implement the spectral splitting technologies into the concentrating collector, and to also develop some conjugate CFD simulations that would allow us to understand how the thermodynamics and the heat transfer is happening in the designs, and how can we further enhance it. For the NEG, which is the National Laboratory of Energy and Geology, they're going to be also supporting the thermal efficiency enhancement strategies that we're going to be implementing, also to analyze the optical performance of the collector. And something that is important in this kind of technologies is to test them. So they are going to be also involved in that. DTU is going to be also part of the testing part in the first phase of the project. And they are going to be also helping us with the control of the system. So I think that's pretty much it from our side. Thank you very much for the opportunity, and you can follow us. We are hoping to have the website ready by the end of this month, but you can always follow us on LinkedIn also to see the updates of the project. So thank you very much.
Thank you very much. And I can see that there's a question in the chat here concerning the PVT application. Now I'm losing track of it.
Yes, the question was about the efficiency of the PV panels inside the Solarus PVT collector, because the temperature is quite high. And sadly, PV loses efficiency with rising temperatures. What do you think about it?
Yeah, that's a really good question. And as you already know, that's what we call a design contradiction, because we're trying to increase thermal or electrical efficiency, but at the same time, we're trying to increase the temperature, right? So this is one of the challenges that we're facing. the current collector could reach between 10 to 13% on the electrical side. Of course, that will be at medium temperature. I'm referring to 60 to 70 degrees on the fluid side. So whenever we would like to push that further into 120, 140 degrees, we will have to look into new PV technologies. We are going to be also like not going into multi-junction solar cells, because that will increase the cost of the collector, but we're going to be going into IVT, which is interdigited back contact solar cells that has a better tolerance to temperature. So yes, that's one of the challenges of the project, and we're trying to push it also with the spectral splitting that will allow us to actually thermal decouple the heat absorber with the electrical part.
I can also see that that this is a discussion that really gets alive in the chat. So I would also very much invite Ivan to respond in the chat to the further questions. And thank you very much for being with us, and much success with your project. With that, I would invite Valérie Séjourné from Solar Heat Europe to make her presentation, where we will see an overview of everything that's happening in Europe. Thank you very much, Valérie. The floor is yours.
Good afternoon, and thank you very much, Gerdy, for this kind invitation that you have made for Solar Heat Europe and this workshop in particular. We are really grateful to make this connection between our work and the work of the CET partnership. So thank you also to everybody for being with us today. So I am Valérie Séjourné, the Managing Director of Solar Heat Europe. And who is Solar Heat Europe? So we are really the voice of the solar thermal industry here in Brussels, vis-à-vis policymakers at EU and national level. We represent the full value chain of the solar thermal sector. We have national association in a dozen of countries. We represent suppliers, manufacturers of solar thermal equipment, and also project developers, energy service companies, research and test laboratories. So this is who we are. You have the full list available on the slides, and you will all get the slides after this event. So in terms of solar thermal collectors, so you already heard about specific technologies, but here in this kind of overview, I wanted to introduce you to the different technologies which exist. We have the non-concentrated technologies on the left part of the slide, ranging from 100 up to 180 degrees. And you see the specific hybrid technology here, which is photovoltaic and thermal, but the other focus on solar thermal solely. And then on the right part of the slide, you see the concentrated technologies, which have linear Fresnel parabolic and which can go up to 400-degree technology. I would like to stress as well that we are really happy to have the Solar Key Mark certification schemes, which is really a proof of quality in terms of performance of the output from these collectors, because most of the manufacturers here in Europe do comply with this Solar Key Mark scheme. So that's, in terms of assurance, very, very good for the end user. Which are the market segments that apply for solar thermal? We have all the users of heat. So from residential, every one of us in our apartments or household can use solar heat. We have the tertiary buildings for hotels, hospitals, leisure centers, etc. And we have also the large scale for district heating and industrial users. I will come to that in a second. So really any type of hot water user is in the scope of solar thermal. In terms of market developments, we are now finalizing the 23 market data. So what you see in front here are still the 2022 data. So we have more than 10 million rooftops equipped with solar thermal in Europe. The total installed capacity is 40.5 gigawatt thermal. We saw in 22 a growth of plus 12%. We anticipate that the figures with 23 may not be so positive, or it will very much depend from country to country. But what we definitely want to indicate is that the market over the last decades has been growing, especially in the last years, and we really want it to even triple towards as we reach 2030 and the CO2 reduction objectives. What's important to see here in this slide is that the biggest market in terms of installed capacity are not the most sunny countries in the south of Europe, but you see that Germany is definitely the biggest user in terms of installed capacity, followed by Greece, Italy, Spain, and Austria. When on a per capita basis, you see that there is a lot of variation, with, of course, countries like Cyprus, Greece being the top users on a per capita basis, but followed by Austria and Denmark closely. So there is great potential for the uptake of solar thermal in other countries like France, Romania, etc., Italy, on a per capita basis. That's definitely the opportunity to grow. What is the policy context that we are in now in May 2024? So we actually benefit from a package of legislations which came out of the EU Fit for 55 through the Energy Efficiency Directive, the Renewable Energy Directive, and more recently the Energy Performance of Building Directive. But basically we see that there is a call for member states to expand the share of renewables, to have some binding targets for heating and cooling, including sub-targets for building, industry, district heating, to accelerate the permitting for cities above 45,000 inhabitants to have mandatory heating and cooling plans. District heating is also having requirements to decarbonize and become efficient, clean and efficient with using renewables, among others. So this is very favorable in terms of policy environment for renewables in general and solar thermal in particular. If we look at the Energy Performance of Building Directive, there is a solar mandate, and I will just quickly show you these slides, which is also an opportunity for us as well as for PV, of course, but there is a requirement under EPBD to really equip the rooftops of new buildings or existing buildings. You see here the progressive evolution of thresholds, deadlines by when all these rooftops will need to be equipped with solar technologies. So this is definitely an opportunity for us for solar thermal and PVT to expand and grow. So if we look a bit quickly at buildings, what we like to say is that the yield in terms of rooftop space needed for solar thermal is 3 times more efficient than for PV. You see a picture on the slide where there is a rooftop which is happily reaching and combining the two technologies, and this is really something which can work well because you make the most of your rooftop by adapting the necessary size that you need for your heat needs and the rest for electricity needs. So this is definitely important to remember, a better energy density for solar thermal compared to PV. PVT, we've heard already through the colleagues, Ivan, about this evolving technology. So we have definitely some very interesting members and successful members in the membership of Solar Heat Europe. And here you see here a picture by one of them of a nice installation in a hotel in Spain. And this hybrid technology has a lot of potential to grow. It is at the moment more applied for tertiary buildings, but we see definitely some potential. And of course, solar thermal can hybridize with any other technology. So this is also something which can very smartly work with heat pump, for example. In terms of district heating, I will not be very long because we have really experts coming on the stage after me on that. But what is important to keep in mind is that Europe has 80% of all the solar thermal district heating here in our continent. So we are really, compared to the global numbers, very active users of solar thermal district heating. 280 towns in Europe are using solar heat, and you see that Denmark is a very important user. Very quickly now to finish the industrial use of solar heat. We won't discuss it today. We will discuss more solar district heating, but industry applications are also definitely in the scope. You see here from food, beverage, paper, textile, chemicals, the different temperature that we can use and that they use and that we can meet with different collector side. We have the biggest installation in Europe is 30 megawatts with Heineken. And half of the industry needs can be met by solar heat. Research, well, this is the research ecosystem in which we have. We have a definite an EU project for renewable heating and cooling. We have also now an implementation working group in the set plan and at IEA level, this research program at global level. So in conclusion, solar thermal definitely has its role to play in the decarbonization agenda. We have a policy framework which is now entering into implementation. So now is the moment to make it happen and make it deploy. We call for the fair treatment of all technologies. Awareness is definitely key. We need that more. So activities like today are really very welcomed, and we need to have also all the enabling conditions, financial incentives, and skills to really support that deployment. I will just finish by promoting the recent manifesto that we released for the upcoming politicians. It's available online. Solar Heat is Smart, and happy to have your questions. And thank you again.
Thank you very much for this for this overarching view on what solar thermal can mean to Europe and is already contributing to the European transition. We have a questions and answers session after the next presentation. So if you have any questions to Valérie, please put them in the chat and we will come back to them after the presentation of the IEA solar heating and cooling task on efficient solar district heating systems. Klaus, can I ask you to come with us and tell us all about it?
Yeah, so I hope you can hear me and see the presentation.
Yes.
Yeah, so I can give you a very brief overview of this task 68 about efficient solar district heating systems. So what I want to show is a very brief general task overview, the motivation, the structure of this task, some applications, and what's the timeline. So as a brief overview, the International Energy Agency was actually founded as a response to the oil crisis in the 70s and is a big organization with lots of activities like strategic oil reserves, publishing statistics, but there are also these technology collaboration programs on various types of energy, also renewable energy. And among those, there is again solar heating and cooling, where we have several tasks as the projects are called there. And one of these is the task 68 on efficient solar heating. So what's the vision? Well, we want solar heating and also solar cooling for secure and sustainable energy for all. And well, we cannot do everything, but we can bring the research results and the information to the experts, to the publics, and be a platform for connection. So what's the motivation? And I already put this nice logo here, designed by one of our partners, Heat is Half. So in a very rough picture, as probably most of you know, but maybe not all, about half of our energy demand is heat, and even of the rest, more goes into transportation mobility than into genuine electric applications. If we have a little bit of a more detailed picture, there it's not on a global level, not exactly half, but very close. So still about half of the energy is carried by heat. It's then distributed quite evenly among buildings, industry, and transport plus agriculture. And if you look, well, the situation has improved, but for many years one has only talked about electricity and renewable electricity, but that's only part of the picture, not the biggest part. And in renewable heat, well, we're at about 10%, so we have to do something about this. And this is main motivation where there exists something like this task. And well, we're here and we talk about solar thermal, but I want to briefly review why solar thermal plants. We heard already about it. So it's of course true that solar thermal plants have a larger energy output than PV. If you combine PV with compression heat pumps, you end up with roughly the same heat output. So it's also clear to say that solar thermal is really strictly better. I wouldn't advocate that, but you have to cleverly choose the right technology. So if you use PV and heat pumps, well, you start with electric energy, which is more versatile than just heat. Heat pumps can also be used for cooling, and small amounts of energy you can store by now quite well in lithium-ion batteries and so on. So this can be a good solution, e.g. for single family homes. But also some solar thermal plants have their merits. So the technology is far less dependent on rare elements. If you think rare earth elements, lithium, cobalt, and so on, you do not have refrigerants which are potentially harmful to the climate and to the ozone layer. The storage of large amounts of heat is much cheaper than battery storage. This can go up to seasonal storage. The integration into district heating grids is quite straightforward. You can use solar heat also for regeneration of ground heat. So this can act as a heat source for ground heat pumps. And last not least, and unfortunately increasingly important, well, the leading manufacturers are here in Europe, so we are less dependent on manufacturers from other parts of the world, less dependent on Chinese technology and so on. And the value chain, the value creation can be kept here. So what do we do in the task? Well, we care about technology, providing heat efficiently at the desired temperature level. We care about handling data preparation, data utilization. We care about cost efficiency, and we care also about efficient dissemination. And there are lots of partners involved. So there are 10 countries, and there are partners from academic universities, research institutions. There are collector manufacturers. There are consultancy companies. There are engineering companies, system designers, turnkey providers. And these are not all, these are just the institutions that were present at the last task meeting. So there are even more partners involved. And the activities are structured in 4 subtasks about concepts and technologies, about data preparation, utilization, and control, about business models, and about use case and dissemination. And all these tasks study technologies and components, but also complete systems. So if you look at applications, for example, as NISNO, heat storage in Groninglund, there is also a very nice article on the Open Data project on this. And one of the activities of subtask B, where I'm involved the most, is to collect data like that and make it available as a joint paper on open data, so which really gives an overview which public data sets are available and how can they be used in the plant life cycle. Or another topic in this subtask is control, where we care about control of component level, but also on system level. So predictive control was already mentioned, and of course you cannot do this or should do this also for complex systems which involve solar thermal plants. So you can create and use forecasts, you can perform optimization-based control and also decentralized systems to handle also these complex energy systems. Actually, this task is already close to the end. So we had a a task meeting about a month ago. There will be another one connected to the USAN conference in Cyprus. And there will be a final meeting in February. Then the task will end, but there will be follow-up activities, or at least they're planned. So if you're interested, if you want to join, just get in touch. Thanks a lot.
Thank you very much, Klaus. This was a real good overview as well of what's happening from the solar heating cooling TCP on the solar district heating systems. I would open the floor for some questions, and these can be questions to Klaus and to Valerie. Are there any questions there? I don't think there are any questions in the chat. Please raise your hand if you want to bring something forward or put your question in the chat. Otherwise, well, I would just reflect on what you were saying, Klaus. The very nice and relevant comparison you made between the PV and heat pump combination and what the solar thermal could do or what would be the response of solar thermal? What is the interesting part? What are the things that we can say in answer to that question? Why would you want that kind of system? Can we have the email addresses of the presenters? I guess you can. The presentations will be shared, of course. So I'm sure that there will be some contact details at the end of each and every presentation. We will make that sure so that you can find the contact details in the presentations. If there are no questions, I suggest that we move on with the next presenter, which is Theo from, we have one question. Marco Lezzi has his hand raised. Can he get the floor, please? And Marco is still muted, I think. Marco, I'm sorry, but if you can put your question in the chat, that will be lovely, and then we can get back to it in the next questions and answer session. So I would like to give the floor to Theo Venema now. He is the project lead of the Warmtestad project in Groningen and will introduce this to a solar thermal district heating system with thermal storage. Theo, the floor is yours.
Yes, thank you. Let me load up the PowerPoint. I guess you'll be able to see it by now. Is that okay now? Let me present. Yes.
It's coming.
Okay, while it's loading up. My name is Theo Venema. I'm from Warmtestad. It's a public heating company in the city of Groningen, the northern part of the Netherlands. Well known because of its big European gas field, which has been closed for almost 1 month by now. And the municipality of Groningen also aims at becoming climate neutral by 2035. And one of the ways in order to achieve this is having their own public heating company together with the water company and delivering renewable heat to households. So we started up in 2014, but actually started construction at the heat grid in 2018, reaching about 6,000 connections by today, and having the ambition of adding about 40,000 more in the coming decades. So we're quite ambitious concerning the growth of the heating company. So our customers, you would not be surprised, of course, mainly housing associations, homeowners. So it's really the urban environment just for domestic heating of buildings. Most of these buildings are, of course, built before the 1980s, so they need quite a high temperature in order to receive enough heat. However, we supply heat at a fairly lower temperature, thus making it an incentive for them to insulate their houses as well and reducing in the heat demand. Of course, if you construct such a heat grid, you will have to need the renewable heat sources as well. At the current moment, we have waste heat from 2 data centers. This year, we will be connecting the solar thermal plants to our heat power plant. And we still need some natural gas for the peak demand situations during winter time. And of course, we use the usual techniques like heat pumps and CHPs and so on for the production of this heat. So our heat plant is situated almost adjacent to the 2 data centers. So that's just a coincidence. So we can easily get their waste heat to our heat plant, and we lift the temperature with heat pumps. And we were quite satisfied having this concept when a project developer came up to us and said, well, we can do something with solar thermal as well. We said, well, no, thank you. We are already well on the way with the data center waste heat, so we would not need any solar thermal. And I'll show you a graph which will show that as well. So it's not the installation at the right side of the screen, but that's a research center, but it's a bit more to the north. And it's just 1 kilometer away. There was a former dredge depot which was being abandoned, and this entrepreneur wanted to make this solar thermal project and deliver, of course, the heat to us. And while that is a very good renewable heat source, we already had enough heat from the data centers during summertime. However, this plant is being constructed, and in a moment it will become clear how this has been done. This is a bird's eye view, an artistic impression still of the solar thermal project. It's actually in the final stage of completion by now. We expect it to become operational in about 4 weeks or so. So all plan your vacations at the end of July, and you can visit this big solar thermal project, one of the biggest in Europe, I guess, consisting of 24,000 solar panels spanning 12 hectares and producing about 25 gigawatt hours per year. So right now we are very happy with this project being finished, because we needed the heat for our heat grid. Well, of course, it's not that complicated if you put it in such an easy picture. Heat is being produced, being stored in the daily storage, transported to our heat plant, and delivered to the houses connected to the heat grid. However, we expanded our heat plants with a seasonal storage in order to accommodate the matching problem from the challenge from matching the supply versus the demand, because as you might realize, demand is lowest during summertime and highest during wintertime. And we already had waste heat from the data centers during summertime, abundant waste heat from the data centers. If you would put expensive solar thermal heat on top of that, it would just be a waste of money, right? So all this heat would be considered as excess heat and lost heat. So if there only was a way to store this heat in a seasonal storage, then it would solve another problem, and that is that during wintertime we actually had a shortage of renewable heat sources, so it could benefit us mostly during wintertime. And that's why we endeavored in developing a seasonal storage system. Of course, we looked into several options, also the pit storage, which is commonly used in Denmark. But we ended up opting for an ATES system, Aquifer Thermal Energy System, which is more or less a supercharged hot-cold system for a different set of reasons which are depicted here. But main reason is that we expect that we would only need this solar energy storage for a limited amount of time, since our heat grid is growing, and then the baseload of our heat grid in summertime will be high enough to accommodate all the solar thermal. So that's why we opted for a very basic seasonal storage system. If you would make a cross section of the soil in our country and in our city, and you would dig about 100 meters deep, there would be a core sand layer, excellently suited to store low temperature heat. And if you would dig even deeper, there you can store heat also at 45 degrees centigrade. So we store at 2 different temperatures, and during winter time we use heat pumps to crank up the temperature and make it suitable again for our purpose. So finally, a few pictures. It's a very robust, easy, simple drilling system. And once it is completed, there's nothing more than a cast iron lid in the street and nothing to be seen here. In conclusion, findings of our seasonal heat storage, it enables us to combine these competitive renewable heat sources like waste heat with summer heat in the summertime for wintertime. We can mitigate any take and pay risk from the solar heat in our developing heat grids. And by having this seasonal heat storage, we can really substantially improve our share of renewable heat in the heat grid. So it's really advisable, especially in starting developing heat grids, to combine this solar heat with a ATES system. That will be all for today. I've got maybe 10 slides more, but the main thing you have already heard by now. So thank you for your attention.
I talked, but nobody heard me.
Okay.
I think there's time for a question, because if I'm not mistaken, you need to leave after 3. But there was one question concerning temperature levels, isn't it, Norbert?
Okay, let me. So I see.
Yes, there was a question about the heat recovered by the data centers. Does it have enough quality to be used in other buildings? What is the temperature level?
So we receive the heat at about 23 degrees centigrade, which is way too low for our heat grid. We crank it up with 2 big heat pumps, ammonia heat pumps, up to 85 degrees centigrade. So we have to do something about it before we can use it. Yeah. So I might be able to answer some more questions now or afterwards.
There's also a question from Michael, as I see it, Michael Hübner, who is the coordinator of the CET partnership. The question is, if I understand it correctly here, would you consider your setup as a kind of living lab? Is there opportunity to do research and innovation there, or how do you see this as contributing to? How do you see the innovative value of this system?
Yeah. Actually, we do have some research programs on top of this system, which is being implemented by KWR at Nieuwegein. They are a Dutch research facility, funded as well by the RVO company of the Dutch government, so to speak. And they mainly research the strategy in loading and unloading of the system, and comparing the fraction of renewables which can extra be used during winter time. So we do not just operate it, but we also try to optimize it and to do some research on top of this. Yeah.
Thank you very much.
Okay, welcome. I'll try to put some answers in the chat as well before I leave. So thank you for your attention.
Thank you very much.
Thank you very much.
And our next speaker will be from Denmark, Plan Energie. It's Daniel Trier who will be taking us into the Danish systems challenges and opportunities and experience. Daniel, the floor is yours.
Thank you very much. I hope you all hear me well.
Yes.
Okay, I will share the screen. There we go. So thank you for the introduction. My name is Daniel Trier. I come from Plan Energie, a consulting company, a non-profit, which just celebrate our 40 years anniversary. We have 3 offices in Denmark, 2 in Jutland and 1 in Copenhagen, and working with strategic energy planning and environmental impact assessments and various renewable energy solutions, with a big focus on district heating, and especially renewable energy sources for that, as well as storages. But today we are going to speak about the solar thermal part of it, so let's dig into that. What we see here is the development of solar thermal in Denmark for district heating, which is the main market, not a big market for individual solutions in Denmark. And actually, the development has been going on since the first plant in 1988. The one which is oldest today, still operating, will have around 28 years of operation today. So it's actually fairly trustworthy to say that it's a reliable technology, which can really stand for a lot of years. And with this development, we also passed more than 1 gigawatt of installed capacity. At the time being, it actually was beyond the PV installed capacity, but PV has sort of exploded since then. A bit bigger map. It's not to scale with the circles here, but this is just to indicate sort of the different sizes of plants, where the biggest one is in Silkeborg. You can see in the center part of Jutland. It's around more than 150,000 square meters of collectors. So today we have around 1.6 million square meters of solar collectors installed. It's almost all of them flat plate collectors in large scale, so roughly 12, 13 square meters per collector. And so the development of this is that we have a lot of decentralized district heating plants, which was based on gas historically, with some legislative limitations on the use of biomass. So it was sort of an obvious choice to invest in solar thermal, which could then lower the cost of heat and replace some gas boiler operation. We also have had some high taxes on natural gas. So combining with the fact that solar thermal could get very cheap loans with the long payback periods, in terms of you don't have to pay it off shortly, but that was accepted, and that could increase the feasibility of solar thermal solutions with a long lifetime, as I just explained before. So we also have a group under the Danish District Heating Association, sharing experiences and collaborating, which is also a benefit for the technologies. Then in the past, we've had some indirect subsidy, you could say. We have had a credit scheme where you would generate CO2 credits you could say, by establishing a solar thermal system. So it could be actually up to around 10% of the investment cost of the solar thermal system, which could be a value generated by these credits, which can then be sold to other district heating companies. It ended, that scheme ended in 2016. Afterwards, there was a similar scheme set up shortly after, which then ended in 2019. That was also a benefit for the feasibility of solar thermal. Then and another part of the development is that heat pumps in district heating is a political priority in Denmark because of the fact that we have a lot of wind power in the electricity system, and we wanted to promote the utilization of that, or the combination of electricity to heat. So there was a financial support for the investment in heat pumps, large-scale heat pumps for district heating, and lower tax for the electricity for heat pumps. And then also, say, sharing of experiences and lessons learned from developing that technology. And the reason I speak of heat pumps is that it has had a big impact on the development for solar thermal in Danish district heating. So shortly about Danish district heating and the energy system, actually around 2/3 of the buildings in Denmark are connected to district heating. So we have a lot of district heating and a big share of the buildings connected. You can say, and also district heating is non-profit, so we can have relatively low costs and also not a competition between the district heating companies, which then again means that they can easily share experiences because there's no benefit of keeping the good ideas for themselves. And most of them are actually cooperatives, so owned by the users themselves. So you could say in the past, we've had a lot of gas-based CHP, and then in combination with that, there was thermal storages in order to enable some flexibility on the electricity production side. In other words, you could produce the electricity and heat when the electricity prices were most feasible or high, and then you can store the heat in the short-term storage for later. This also means that a lot of district heating companies already had a thermal storage when they installed solar thermal, which is, I wouldn't say even just useful, I would say more or less mandatory to enable the large share of solar thermal. And then today we see another development that it's actually more flexible demand of electricity, meaning the flexible use of large-scale heat pumps and electric boilers in district heating. We also have a higher electricity demand for power to mobility and so on. And in the coming years, we will probably see more power to X with a lot of use of electricity, also enabling excess heat to be used in district heating. So all of this, in combination with the development of solar thermal in Denmark, means that today, in the past 3 years or so, we've seen almost no development in the solar thermal market in Denmark. You could also show it in another way. These bars show the annual installation of solar thermal. And as I mentioned, the incentive scheme ending in 2016 meant a lot of things are being done just before the deadline, then almost nothing in 2017. Something similar happened in 2019. So yeah, one example of a recent system being installed actually with both solar thermal and a heat pump. Here we see a roughly 6 megawatt solar thermal system and a 3 megawatt air source heat pump in the upper left corner. So this is actually one picture of the combination of both technologies, which in many cases compete, but could also, let's say, collaborate. So I will skip these, I think, but these are just a few points of what happened to promote the heat pumps, which is then indirectly affecting the solar thermal market. Another development based on the solar thermal the historical development is that large-scale peak heat storages have been developed as a technology. Previously, it was mainly for storing solar thermal, but actually today it's also used for balancing large district heating systems, not only with solar thermal, but also with other solutions. A few pictures here. This is how it looks like today on the top, where you can actually walk under the lid. So to conclude, I will just mention that more information on these developments over time in Denmark is found in this publication. And we are also part of the Task 68 project. And in case you have any further questions, you're welcome to ask them directly to me. Thank you.
Thank you very much for this interesting trip into Denmark and the way solar thermal has gotten its feet on the ground in large-scale systems in Denmark and what happened next. I would like to introduce the next speaker because we have a questions and answer session after the next speaker, who is Magdalena Beberich from Solites. Magdalena will be representing the German situation. The floor is yours.
Yes, thank you. And I share my screen so you can see now the presentation in full screen mode. Thank you for the invitation to this webinar. I'm very happy to introduce to you today the German solar district heating market with some examples and an overview and some research topics. So we are Solites is a Steinbeis Research Institute in Stuttgart in Germany. And we are focusing in our research on solar district heating, on shallow geothermal and simulation studies and consulting, and also know-how transfer like today. So our goal is always to have or to create energy supply systems with minimized emissions and to take part in the decarbonization of district heating. One example for a 100% renewable heat supply in a village in Germany is the solar and bioenergy village in Mengsberg. Here wood chips and solar thermal and a small part of biogas are supplying the heat to the citizens in the village. And here about 2,950 square meters of collector area and a buffer storage with 300 cubic meters are installed. What is the specialty of the system? It's in Mengsberg an energy community which owns the district heating system. So they made a first feasibility study in 2013, then founded a cooperative, made contracts and so on, and then built up the district heating and the solar thermal plant and the heat supply. So you see here in the timeline, it's a long way from the first feasibility to the heat supply with 100% renewable heat for this village. And here the energy community, it's 141 participants which own the district heating and manage it. And they all took a deposit per building and for the piping and the transfer station, and then they are connected to the district heating system. So like before, it was mentioned already that accelerating the supply with renewable heat in district heating is really a topic, also for energy communities and for the whole systems and the market of district heating. we need to decarbonize district heating to have the climate neutral building stock like it is planned, for example, in Germany by 2045. And this is why we investigate more in detail in a EU project how energy communities can take an active role here in the heat transition, and because we think it's very important to have this bottom-up initiatives and to have all the citizens to take part in the heat transition. So this is the project Connect Heat, an EU project which is an initiative to develop heating and cooling communities in Europe. And we create concepts, develop manuals and so on to support initiatives. We have real pilot cases in 7 different locations in the participating countries. And as you see here, if you are interested in more information, there's a LinkedIn channel and also a newsletter on the website. And if you want to know more about bioenergy villages and solar energy villages in Germany, there's also a manual, unfortunately in German, but maybe for some of you interesting, you can read some about more examples in Germany. How's the solar district heating market in Germany like? We have 55 plants in operation in Germany with 160,000 square meters of collector area. And we have even 9 plants in realization, and in preparation there are 70 plants. So we have a good development in the market, and we have a lot of plants already installed and a lot are coming. These are like bioenergy villages like Mengsberg, but also small towns or urban solar district heating, or also collectors on buildings. More information we have gathered on our website solarwärmenetze.de. How is the development supported by laws and funding? As I mentioned, the climate neutral building stock is planned in 2045, and there's also mandatory local heat planning for all cities since 1 year. And there, the definition of areas for district heating and for single house solutions is necessary. Additional, a new national law, the Building Energy Act, is in place where the new systems for heating in houses need to reach 65% of renewable share, or they need to get connected to district heating. So, and additionally, district heating needs to make transformation plans, how they can decarbonize their heat supply. And to support this, there's also a subsidy program, Efficient District Heating, since 2022. And there's funding for invest and for operation. So in sum, you can around 50% of the invest you can get, like for funding. We have the next step now in the size of solar district heating plants in Leipzig, with 65,000 square meters of collector area. It's the largest plant now in installation in Germany. And here the collectors deliver heat with up to 110 degrees C to the city's district heating network. In this field of the temperature level of the supply of solar district heating, we see some more research topics. As mentioned already in IEA SHC Task 68, where I'm also involved, we we are creating a report about the analysis of different collector technologies which are interested for district heating. So for each temperature level, there are different technologies, and we are comparing how they can be used in district heating. And we have a just brand new German research project, Netz, where we also want to elaborate this topic more. And another research topic, as mentioned before by Daniel, is the thermal energy storages, like here pit heat storages. We see research topics also in the system integration of the heat storages and the solar thermal plants, but also in the construction methods and materials to have a long lifetime of these constructions. Another best practice in Germany is the energy concept for Hechingen. It's a new building area, and here's also around 100% of fossil-free district heating plants with solar thermal, with seasonal heat storage, and with shallow geothermal and heat pumps. If you want to have more information, you can see here our website and LinkedIn and newsletter. So you can have a look here. And if you want to know more about the IEA Task 68, you see here some information and my contact. So I hope it was interesting for you and looking forward to your questions. Thank you.
Yes, thank you very much for this presentation. Also interesting to see what's happening in Germany, and this also makes me think about the Renewable Energy Directive of the European Commission that is really much more underlining the importance of the transition for the heating and cooling operations as well, away from the focus they earlier had, where energy and electricity seem to be synonymous. There are some questions, I think. Norbert.
Yes, there's a question for you, Magdalena. How sustainable really are wood chips? Where do they usually come from? What programs are in place to ensure they come from sustainable forestry?
Yes, of course, there's a big discussion and depends a little bit on the region and on the country where you are, if wood chips are really sustainable or not. So I think it's in some part it can be sustainable, but of course it's not possible to supply all the heat in district heating with wood chips, because if you have too much wood chips produced, it's in the end it cannot be from the same region, and if you go too far with the production of the wood chips, so you need to deliver it very far, then it's not sustainable anymore. But I'm not an expert on that, so I cannot say something about the future developments here.
Mm-hmm. Maybe if I'm thinking about the systems that are now installed in Germany, large-scale district heating with the aid of solar thermal, I can also see that it is a combination of various technologies to get the heat, to produce the heat that you need. Do you feel that there's a lot scope for further development of that? How do you see that?
Yes, as you mentioned already, there's always it's always interesting to have a combination of different heat sources and renewable heat sources, because yes, solar thermal cannot be the only heat source, and so we need to investigate in how to combine the components so that it's an optimal overall system and to supply the heat the most efficient.
Mm-hmm. Thank you very much. Daniel, do you have another view on this or anything to add?
I might say that so one thing is the efficiency and feasibility of solar thermal as it is today, but I would also argue that I don't see a large increase in cost for solar thermal, and the electricity demand for the pumps is more or less neglectable. So the cost of solar thermal is more or less what it is today, and then it depends on the interest rate of the loan, I guess. Whereas electricity prices for heat pumps, for electric boilers, biomass prices, besides the gas prices and also taxes, I guess, if we want to phase it out, all of that will increase. So I think that might be a future advantage for solar thermal. So not more efficient systems, but everything else might increase in costs, making solar thermal more feasible.
Mm-hmm. Do you see any critical improvements that solar thermal systems or systems incorporating solar thermal applications need to establish between now and well, 5 years?
Well, I think there's a big potential of lowering the temperatures in the district heating grids. So I think that would benefit solar thermal as well, and also enabling other technologies for thermal storages together with solar thermal. Whereas if you stick to requiring 110 degrees, for example, in the grid, then it would lower the feasibility of solar thermal in some cases, and other renewable energy technologies as well, I might add.
Yes, thank you for pointing this out. Norbert, do you have any questions, or shall we ask for a last round of questions?
No, I don't have any, and I think the other speakers have answered just some of the questions in the chat, and so.
Do you have an observation to share with us as well, Valerie, on the wrap up?
I would like to thank all the speakers, because it's been really very interesting to hear the different perspective and the complementarity as well of the work, working from the experience of Denmark, which is so knowledgeable on the scale of solar thermal district heating and why things are changing, but still with very important messages on the fact that if the capex can be supported with adequate finances, then users can rely on a very constant and reliable price for 20, 30 years. And I think this is really an important message, so that's really a very important thing that we need to promote, and that users, authorities, financial institutions are to embrace, because there are not so many energy sources which can claim that. So thank you, Daniel, for this comment. And yes, I think the research needs to continue. The storage capacity, the thermal storage of our technology, again, with all the experience which have been gained elsewhere, is also, in terms of cost of thermal energy storage, something much more competitive than electricity storage. So definitely something to capitalize. And then I think, according to the different situation, the different geographical areas, the more local sources exist. We heard the case of data centers in Groningen coupling with solar thermal. By all means, let's use, if there is a big potential for geothermal in this specific village which needs heat, let's make use of it and complement with the other sources. So I think the energy transition needs to use all this variety of sources and make the best of them and optimize them with the right synergies together. So whatever can be addressed by these off-grid solutions to put less pressure on the grid is to be embraced and welcomed and supported politically. So thank you again for this opportunity, and happy to pursue the conversation in the partnership or in the Solar Heat Europe discussion as well.
Thank you very much. I think we're going to, there are some questions in the chat again. So for Daniel, and also a more general question. So if you could just try and say a few words about this in the chat, I will go to the last slide that I have to finalize this webinar. Because I have, of course, some news to share also from the CET partnership. We will have our next call pre-announcement event on the 4th of July, where you will be taking into what it takes to build a CET partnership project and all the things you will need for that. You can go to the CET Partnership website to find out about it. And also there's the draft call text, as I'm informed. So, so with that, I want to thank you very much. And I want to thank all the speakers also of today for their contribution to this event. And I would also invite you to share with us any feedback on this event that you may have. Please use the email address TRI4CETPartnership.eu. And with that, I wish you a very good afternoon, and thank you again for being with us. I hope to see you again soon within or outside the CET Partnership collaboration. Thank you very much.
Thank you as well. Bye.
Bye-bye.
Bye-bye.
Thank you.
Thank you very much for coming.
Thank you. Bye-bye.
Thank you very much.
Bye-bye.
Well, there's still 20 persons online, but thank you all speakers of today. It was, I think, a very lively and nice opportunity to be with all of you, and I'm very happy that we've organized it like this. Thank you very much. We will put the presentations online, have a few words. If you want some sentences to be included in our report, which we will publish on some website, please send it to TRI4@CETPartnership.eu or to Esther or Alicia, and they will pick it up and work with that. And we will see each other again, I'm sure.
Thank you again from my side. That was really well done. Good. Looking forward to following up the discussion and the good work.
Okay.
Likewise.
Bye-bye then.
Bye.
Bye. Bye.